Welcome to a slow, beginner-friendly lesson on invoking a Python lambda with the AWS CLI, made for absolute beginners. Time to call it. Last lesson you deployed a function. Today you make it answer. We use AWS lambda invoke from the command line, pass a JSON payload, and read the response from an output file. We also meet the two invocation types, synchronous, where you wait for the answer, and asynchronous, where you fire and forget. By the end you will know exactly how to call a lambda and read what it sends back. Make it answer. Here is the layout for this lesson. A folder named invoke_project. Lambda_function.py is the same handler you deployed last time. We will not redeploy, just call it. Event.json is the payload you send to the function. Response.json is the file AWS writes the answer into. iProject.toml holds project metadata. 3 small files, 1 function in the cloud. 3 small files. Create the project with UV in it, then change into the folder. Confirm the AWS command line is installed with AWS version, and that your profile and region are set with AWS configure list.
Optional but recommended, install JQ, a small tool that pretty prints JSON in the terminal.
You can install it through Brew on a Mac, or as a development dependency with UV add --dev. JQ is not required, but it makes responses much easier to read. Tools first. One command carries the whole invoke. AWS lambda invoke takes the function name, the payload file, and an output file. The payload is what you send in. The output file is where AWS writes the response. After the command returns, cat_response.json shows you what the function returned. That is the basic rhythm: send a payload, read the response, understand the answer. One command carries it. Your function lives in the cloud now. It does nothing until you call it. Today we make it answer. The function waits. Here is the simplest invoke. Event.json holds a single key, name with the value ADA. The invoke command sends that file as the payload. When the call returns, AWS prints a status line, status code 200, meaning the invoke succeeded. The actual function response is not on your terminal yet. It went into response.json. You read it next. Send and receive. Lambda speaks JSON. The payload you send is a JSON document, usually a single object with keys. A simple payload has one key, like name. A richer payload has several keys, like name, language, and uppercase. Inside the handler, that JSON arrives as a normal Python dictionary, so event.getOfName returns the string ADA. Whatever you put in the payload shows up in the event argument. JSON in, JSON out. After invoke returns, the response lives in response.json. Cat it and you see the raw JSON the function returned, status code 200, body hello ADA. Pipe it through JQ for a pretty indented view, or JQ.body to pull out just the body field. Reading the response file is the second half of every invoke. Without it, you only know the call succeeded, not what came back. Cat the file. Here is the full cycle in one view. You write a JSON payload into event.json. You run AWS lambda invoke with that payload. AWS sends your payload into the function runs, and its return value flows back. AWS writes that return value into response.json. You cat the file and see the answer. 5 small steps, end to end, every synchronous invoke. The whole cycle. Every invocation is a question and an answer. You send a payload in. The function returns a response out. A question and an answer. Modern versions of the AWS CLI default to passing the payload as raw JSON, which is what you want. On older versions, the CLI expects the payload to be base64 encoded, and a raw JSON file fails with a confusing error. The fix is the flag --cli binary format raw and base64 out. It tells the CLI, what I am passing is raw JSON, please send it as is. Add this flag and your payloads always work, regardless of CLI version. The flag that saves you. When a lambda sits behind an API gateway, the event it receives is much richer than our simple name payload. You see HTTP method, path, query string parameters, and headers, everything an HTTP request carries. The handler reads event.queryStringParameters.name to find ADA. You will see this shape again in later lessons on API Gateway. For now, just know, the event reflects whatever called the function. Richer payloads. When a lambda runs on a schedule, say, every morning at 8, the event looks different. It comes from Event Bridge, not an API. You see a source field set to AWS.events, a time field with the trigger moment, and an empty detail object. There is no user input. The function does its work on its own, like an alarm clock. Same handler, different shape of event. The handler decides what to read. Time-based payloads, whatever your handler returns is what shows up in response.json. A common shape for API gateway backends is status code, headers, and body. Notice that body is a string, usually JSON serialized. That is because the body travels over HTTP, and HTTP speaks text, not dictionaries. The caller parses the body back into JSON. Hold this idea, the return value of the handler is exactly what the invoke writes to disk. What comes back? Lambda supports two invocation types. Request response is synchronous, your terminal waits until the function finishes, then prints the status and writes the response. Event is asynchronous, AWS accepts the payload and returns immediately, and the function runs later. With event, there is no response to read, so we send the output to dev null. The default when you emit the flag is request response. Most beginners want synchronous first. Wait or fire, sometimes you wait for the answer. Sometimes you fire and walk away. Lambda supports both. The choice is yours. The choice is yours. Let us walk the whole cycle with a real payload. Step 1. Write the JSON into event.json, here, name Dennis. Step 2. Run AWS Lambda invoke, pointing at the function and the payload. Step 3. Cat response.json pipe through jq.body to read just the body. You should see hello Dennis. 3 steps, 1 answer. This is the daily rhythm of working with Lambda. Walk the cycle. 3 errors come up often. First, function not found, you mistype the function name or you are in the wrong region. Second, invalid payload, your event.json has a JSON syntax error, like a missing comma. Third, forgetting the output file argument, without it, the invoke has nowhere to write the response and AWS refuses to run. Read the error slowly. The message tells you what is wrong. Read the message. Quick self-check. Can you write the invoke command from memory? Can you explain why you need an output file? Can you describe the difference between request response and event in one sentence? Can you say what an API gateway event looks like compared to a scheduled event? If any feels shaky, rewatch the matching part. The goal is the rhythm, payload, invoke, read. Say each out loud, hold the whole picture. AWS Lambda invoke is the one command that calls your function. You pass a JSON payload. You name an output file. AWS sends the payload in, runs the function, and writes the return value to the file. Synchronous invokes wait for the answer, asynchronous ones fire and forget. The handler's return value is exactly what you read back. That is the entire invoke model. One command, one answer. You can deploy a function and you can invoke it. The natural next question, when something goes wrong, where do you look? The next lesson answers that. Lambda writes everything your function prints to a service called CloudWatch Logs. You will learn how to list log groups, read the latest events, and tail logs live while you invoke. The handler is no longer a black box. Logs are next. Here is a trick that saves you a trip to CloudWatch. Pass -- log type tail to invoke, and AWS returns the last 4 kilobytes of the function's logs in the response, encoded as base 64. The response carries a log result field. Pipe it through base 64 -- decode and you see the prints and logging output from that one invocation directly in your terminal. For a quick debug, this is faster than opening CloudWatch. Logs in the invoke response. If you want a quick practice, run the invoke cycle with several different payloads. Send name Linus and see the body come back with Linus. Send an empty object, curly braces with nothing inside, and confirm the handler falls back to its default world. Watching the response change with the payload makes the model click. The function is a question answering machine, and you now speak its language. Try a few payloads. Thanks for invoking your first Lambda. Next we learn where the logs live. The function answered.